Hi, my name is Jesus Cervantes, and in this video I'll be walking you through our segmentation process for generating three-dimensional models of the hip to better assess femoral acetabular impingement syndrome. Here are our disclosures. We begin by uploading DICOM data. Under the Add DICOM Data module, we select the Import DICOM Files tab. This allows users to upload their patient of interest to complete their segmentation on. To ensure patient privacy, we de-identify DICOM data. This process starts by double-clicking the sequence of interest and exporting it as a DICOM. We use the DSCI Slicer Batch Anonymize extension, which can be downloaded to 3D Slicer. Under the Slicer Batch Anonymize module, the recently exported DICOM is selected as an input, while a new output is generated. This output is now de-identified and can be used for segmentation. Under the Segmentations module, we begin by creating two segmentations of focus, one femur and one pelvis. A thresholding range is then applied for masking, such that the areas of bone are highlighted in green. For this 3D MRI, the threshold typically ranges from 10 to 200. The femur and pelvis segmentations are then segmented independently using the paint and erase functions under the Segment Editor module. The masking range can be altered if needed in cases where the bone is not completely painted. For final pixel sizes, the oversampling factor can also be increased from 1 to 2, which is useful for painting along the cortex. Now this process is then repeated on multiple slices along all axes for both the femur and the pelvis. To help the software distinguish non-target areas, we create a not bone segmentation. On this segmentation, areas are painted that do not consist of the femur and hemipelvis of interest. Attention is made along the articular cartilage between the femoral head and the acetabulum. Once completed, we move on to the Grow from Seed step by clicking the Initialize button. This process may take several minutes due to the amount of computational power required. We receive the coarse segmentations, which still need refinement with the erase and paint functions. Once satisfied with coarse segmentations, the Apply tab is selected. Here we obtained a coarse version of the model. To clean the model, we begin by erasing obvious areas of artifact until the segmentation is sufficient for smoothing. The smoothing process starts by using the Islands tool to keep only the largest island and remove smaller ones under the Segment Editor. We then switch to the Smoothing tab. For the hip, we use closing or fill holes at a kernel size of 5 mm and opening or remove extrusion at a kernel size of 5 mm. Finally, the smoothing process is completed with median smoothing at a kernel size of 3 mm. Any small corrections can be made at this step using the Erase function and followed by a final median smoothing step. This exact process is then repeated for the hemipelvis to generate a complete 3D model. Here we appreciate the final 3D model of the hip joint. There are various clinical and research applications for the use of these models. For example, analyzing the 3D structures allows for preoperative planning in situations where only an MRI is available, and morphometric analysis of the model can be used to investigate research hypotheses. This model can then be exported as an STL file under the Export to Files tab in the Segmentation module.